So welcome everyone. I am Valdis Saulespurēns. Some of you might know me. I'm a lecturer at the Riga Technical University, and I work at the library here as a researcher. And today we will be holding an intermediate Python seminar or workshop on text content analysis. Also, by popular demand, of course, we will be using AI tools. We will explore some of the ways large language models can assist us in our coding tasks, in text processing, so make our lives easier. So a little bit about me. All right, so I've been programming for over 30 years, and Python, I think 15, 16, 17 years now already. I'm teaching Python for about 6 years. So how to get in touch with me if you have any questions after the workshop? You can see me here. So Valdis Saulespurēns at LNB.LV, right? That's the email, right? There's also LinkedIn and also a GitHub account. Good morning. All right. So the main content of all this workshop will be available at this link. Right? So you might have seen the materials of the previous year. So all you have to do is change 3 to 4. Right? So these will be the most up-to-date notebooks, materials, data. So it's not the end of the world if using the old one, but of course I would highly recommend you use the current one. So our program will be today. We will look at collecting data, pre-processing data, and tomorrow we will be looking more at modeling, maybe some visualizations. Also, as you noticed, we are meeting a little bit early, right? We were planning to do this in an hour and a half, right? So we were moved ahead of time. So we start 9:30. Technically, this first part goes to 11, but we will stop around 10:55, take a short coffee break, right? And then continue around 11:05. Then we do the second part, then we have lunch, and at 1:30 we do the third part today. We have two assistants. I have two great assistants here. Artis, yes, my colleague. He will be assisting with local inquiries, meaning on site. And Viesturs, right, or my new colleague. And he will be assisting with remote queries or online Zoom queries, if you have any questions there, right? What I will be doing, if you have any questions, I will try to batch them up, right? If there's nothing completely critical, I will take some time to ask some questions, but for you to give me questions, but I will try to move at a slightly quick pace. So the pace of the warning is, of course, the pace will be quick. Idea is maybe you will not be able to catch everything, but you'll hopefully, from this workshop, you will get some ideas on how some tools, you will improve your tool set. Your collection of hammers and other tools will get wider and bigger, basically. That's the idea. All right, so let's take a look at, so everybody has I assume everybody has a network access, everybody has a computer, right? So I assume, since this is intermediate, that you guys know at least a little bit of Python, right? Everybody knows some Python. You can write a hello world, you can write maybe a fizzbuzz, right? You know how loops work, how if statements work, maybe you know about lists and dictionaries, hopefully. Those would be the minimum requirements. Again, so now the question is about notebooks. So who has been using notebooks, Jupyter notebooks? Everyone, or most of you, at least to some extent, right? Again, so it's not absolutely required because, of course, underneath, what's Jupyter notebook? It's basically just another way of writing code. It's a way of combining text, annotation, with actual Python code. Really, it's just a more interactive way of doing it, but underneath is just a text, same as writing just a regular program. Good morning. Right, so now about the setup. This is the hardest part, so we'll get over this hardest part of the workshop immediately, is we have two ways of working, basically. Locally, on your computer, or on the cloud, right? On the cloud version, which our colleagues next door are using exclusively, is the easiest, right? You just click on a link, you go to Google Colab, there are other ways, right? And you don't have to do any installation, meaning all the code runs actually on another computer. You know, cloud is just somebody else's computer, of course. So, and your computer is just a terminal, you could say a dumb terminal. Basically, you're just writing instructions, but the actual work happens somewhere else. And that's completely fine way of working, right? And I assume, again, if you encounter any technical issues with local installation, then it's completely fine to use Google Colab. So, what I would think is here, you can see this link. I don't know if you can. So here's a link, test minimal prerequisites, right? If you click on this link, right, I'll show you, right? I'll open a new tab, right? So you go to Google Colab. For those who have not used Colab before, right, this is basically Jupyter notebooks running on a Google infrastructure, very popular. It's free to use as long as you have a Google account, right? There are also paid versions available, but you don't gain much from that, and you need to have a connection. So you need to connect, right? What happens then? Google creates a virtual server for your own needs, a temporary server somewhere in their data center, maybe in Finland, maybe in Germany, and you can check how much memory you have. You have maybe 12 gigabytes still, 100 gigabytes of the drive space. Pretty nice setup for free, right? And then how do you run these notebooks? Again, this for most of you, this will be second nature. You can either press Control Enter or Command Enter, or just press the mouse on Run Cell, right? And of course, you'll get a warning. This notebook is not authored by Google, right? Which is fine because this comes from me, right? And you run the code, and it will run a short test, right? It's adjusted a little bit. I'm not going to go into detail on this, but basically we'll try importing some libraries, right? So which are widely used, because of course Python has standard libraries, which are always come with a Python, batteries included, but also you have some external tooling like Pandas, which is very widely used for data processing, data analysis. For example, you have a GenSim, which is for topic modeling, or scikit-learn for machine learning in general, or Plotly for plotting. The good news is, basically for NLP tasks, good news is that Google Colab already, the servers they spun for you, already includes everything. So that's the nice part, right? So everything is there. You can check, right? It works. It checks, gives you the versions. What's interesting is Google is very conservative, right? It's using Python 3.10, right? What's the current version? Which one? 12, yes, 3.12. Actually, Python is very, how should I say, well organized. Every year around October, November, October usually, you get a new version. So we are on 3.12. We will have 3.13, right? So Google is using a version of 2 years ago. That's not the end of the world, actually. Python supports about 5 years worth of versions, right? You usually, I mean, if you're working locally, you want to be on the latest, but you don't want to install Python in October when the 3.12.0 came out, right? You don't want to usually do that. You want to wait maybe a month or two, right? So we are in good shape here because this is summer, so by now any bugs, any incompatibilities have been worked out. So you can be safely on 3.12, 3.11 is fine. I would say 3.9 is probably still okay, right, if you're on computer. But yeah, if you're on Colab, Google gives you 3.10, right? And also, similarly, all the other versions of these external libraries, of these external tools, they're not the latest, right? Because they, again, go back maybe a year and a half, right? But this is completely fine. It will work, right? What's interesting is now, I noticed this just recently, that Google finally made through on its promise. This is like 2 years ago, I already saw it. They were promising this like 2 years ago. They were promising AI assistants, and they finally have some assistants. So you can actually write some code with AI. Like we can try, let's say, what could we do this? Generate with AI, we click, right? And yeah, you have to accept this is experimental technology. Like I said, Google is running really behind. And I will write something. What should we write? write a greeting. It's a greeting for digital humanities. This will be very simple, right? Humanities that runs, 5 times. This is very simple, right? So, and let's see what it does. It should be very, very, yeah. And of course, this is a loop, right? We all know the loops, and we know. Can you see this in the back, by the way? Right. So, I also noticed, since this was such a simple prompt, right? It only had one version. I was playing this around with this a little bit a while ago. Sometimes it will give you like 4 versions. Has anybody else tried this? This new assistance from Google? Right, a little bit, right. So I'll be honest, I'm not a big fan of this yet because it's basically just like using maybe ChatGPT, right? It's not not a smooth way of working. What I'll be using in this workshop, and hopefully some of you also will be able to run, is I'll be using GitHub Copilot, which gives you much smoother workflow. Meaning, when I write something, the AI assistant works in the background constantly, and it's kind of like having a second mind and having an assistant, really. It's much more seamless, right? So you probably heard of this theory that human mind can only hold about 7 or 8 concepts in a short-term memory, right? Like maybe 8 variables, 7 names, some things like that when we are thinking, when we are working. And so if you have to look into something outside help, right? So you need to swap out the space, right? So this approach, just like using ChatGPT, is you sort of lose this speed. You have additional latency, delay, basically latency, right? So again, but it's okay. It's good. It's a good thing. Okay, it's a good thing it exists. There's a recording in progress. That's good. All right. So. Okay, but so yeah, this is all if you have a network connection, assuming again those who are remote, they obviously have. Locally, you guys also have a connection. Hopefully, the password is there, right? In case you need the Wi-Fi. Right. So this will be okay. So I assume it will work for everyone, right? So now we will move on to the painful part, right? First, yeah, again, there was a refresher. If you want to refresh your Python knowledge, there's another notebook. But now let's see about the local installation. I can't spend whole day on it, unfortunately, right? But the question is now, how many of you have a local Python installed? 1, 2, most of you. Excellent. So you're good. So again, I'll be using Visual Studio Code as my editor of choice. But so how many Visual Studio Code users? Almost everyone. Some PyCharm user? No? Yeah, IntelliJ is fine. Yeah. Like I said, the main idea, of course, is it doesn't really matter what we are using. We are, at the end of the day, we are writing text, right? Writing programs, of course, is writing text. In some way, structuring text, of course, right? So PyCharm is completely fine. IntelliJ is fine. But of course, for this workshop, I'll be using Visual Studio Code. So Visual Studio Code, Python, we can write hello world, that's great. But now, of course, also, how about Copilot? Who has installed Copilot now? 1, 2, good. 3, yes, very good. Artists, not yet. Okay, so 3 people have it. So they will have the easiest time of following me. Right. Again, it's not the end of the world if you don't have it yet. I will show you briefly what's involved. So let's go. How would you work on following these materials locally? Again, if you are remotely, you can use the Google Colab, and again, you don't have to do anything else. But now, of course, if you're using locally, you have Python installed, you have a code editor, PyCharm, Visual Studio Code, or Atom, or some other ones. What's the new one? Z is the new one, right? Anyone heard of Z? Not yet. Okay, good. All right, but it's just a tool, right? So we have these materials for this workshop, right? So GitHub accounts. So how many people have GitHub accounts, right? Most of you now by have, right? So again, not a requirement for this workshop, but it will make your life easier if you do, right? GitHub is owned by Microsoft for about 5-6 years now, right? It actually was a startup. It's it's a place for, it's a hub for storing source code or any type of, well, materials, code, text, but most popular in the world. I think Microsoft paid about $8 billion for it, like about in 2019 or 2018, right? And why did they pay for it? Well, because they wanted the mind share, right? They wanted or access to all the greatest minds, right? And of course, some of the code, if you use the open license, was used to train the AI assistants. So in some ways, you can feel you helped OpenAI and Microsoft build their models, right? Not everybody's happy about this. I don't mind, all right? But it's not a right. It's not a completely one-way street. So, but yeah, but you have this site, right? So there are two ways of doing it. If you already know Git, you can find the address here and you can clone this repository, right? But I'm not gonna, in this workshop, I'm not gonna spend the extra 10, 20 minutes working on Git, right? If you know Git, that's great. If you don't have Git, you can just download the zip file. Like if you don't have GitHub account, right? This is an open repository. It will stay open after the workshop, right? You can just download the zip, right? And then open the zip in some folder on, let's say I'll show you, right? And you can just download it, right? Let's see how quickly it goes. Did it actually download now? I didn't even try it. Or is it a network? It's not very big repository, so it should have been downloading it. I don't see it actually here. Oh no, maybe here now. Oh, that's interesting. Oh no, it is. Well, my internet access is not very good here, unfortunately. Right, everybody's downloading it. But yeah, so that's the way of downloading the code, and you unzip it, and then you have some folder. Like usually, right? You have some project, you work on a folder, and you have subfolders and folders and so on. But okay, but I already have this open. So let's assume you have this code, right? Oh yeah, it did download. Yeah, it did download. It was thinking, right? It shouldn't be too very big. Yeah, it shouldn't be big. It's okay. We don't need the app. Yeah, but yes, I'll stop. I'll pause it. But yeah, it will download, and it'll be a zip file, and you know how to open a zip file. I hope. Right. So. Now I'm going to open up my Visual Studio Code, right? And again, I assume if you have Visual Studio Code already installed, it follows a standard approach. You have a IDE, Integrated Development Environment. IDE, that's what it stands for. You have an Explorer, you have a File Explorer, right? Tab here, right? You have Search tab here, right? And we have source control, that's okay. But also you have extensions, right? So, Visual Studio Code, to work with Python, you need Python. So I assume, again, you need a Python extension. Why don't I have it here? But obviously, it's now, oh yeah, installed. Now I have Python installed, of course. It doesn't show anything. The filters, no. Yeah, I assume it's because of the network, right? So yeah, but yeah, it will be interesting today, I'm sure, right? So, but yeah, you can see what I have installed. I'll show what you basically need installed. Basically, you need the Python, right? This one here. This is what you need to install, right? And it is actually it's official Microsoft extension. They don't include it with Visual Studio Code, but they probably should. But it's installed. It's installed how many times? Like 40 million, 120 million times. Like details. You can see this, right? But yeah, okay. So you need that, and also if you want to run it locally, you also need GitHub Copilot, right? So this is what your AI assistants will come from, right? It's another extension. Again, Visual Studio Code has very many extensions, right? So you install this extension, but you also need to have a GitHub account, and you need to sign up. You need to activate this this Copilot. And let me show you here. Where is it? Yeah, this is all instructions. And where is my instructions now? Yeah, here, right. So you need to sign up for Copilot. And again, the network is really slow because everybody's using it. Let me see what's happening with the network. Performance and network, Wi-Fi, very, very slow. It looks like something days of 1990s. Yes, right. So, like when modems, who has used the dial-up modems? Some of you have, right? Yes. So, but okay, we'll get there. But yeah, so there's a link to that actually in our materials. And then, so basically, you sign up for the Copilot program. And I should mention, if you have some academic affiliation, if you're a student or a teacher, it's free. That's a good part, right? If you don't have any affiliation, it's 10 euros a month, but you have 30-day free trial, and then you can decide. I think it's 100 euros a year, right? And I was one of the early testers, like in 2021. I was lucky enough to be one of the early testers for Copilot, but and afterwards they made it free for students, but not for teachers. So I was paying out of my own pocket for about a year till they actually made it free to teachers as well. Finally, they realized they gave some love to teachers as well. But yeah, but I think it's definitely worth it. Of course, there's some competition. I should mention, yes, there's alternatives. That's really good news that if you don't like Microsoft, you don't like OpenAI, there's some philosophical issues with them. They're not really open, right? You have some options. If you have a good enough computer, you can actually install some models, AI assistance tools locally. I should mention that. It's a very interesting topic. You get very good quality, not as good as maybe as Copilot, right? But very good, but it's locally, meaning nobody has access to your data, right? You have a nice beefy graphics card, and you can run your models locally. And there are also, of course, other competitors like Mistral, for example. Of course, from Facebook also, Yama models, of course. So yeah, so things are changing. Basically, literally every week, something new happens. But yeah, but Copilot is the oldest one, and it's most established, and has the most, I would say, crowd share or mind share. And that's still I've been using. I'm very familiar with it. But the principle stays the same, right? So okay. So now. It's finally loaded. Yeah, so if you see, get started with Copilot, again, you could spend some time. And again, I think it should mention the pricing, but it's like I said, I don't think I'm going to be accessing any external sites too much. It's just too slow. Yeah, let's see here. Yeah, still slow. And now, so again, again, reminder, you can use this notebook from the Google Colab, but I'll be using it locally. So this means that I have somewhere on my computer, I have this data, this source code, and I'll show you where it lives on my computer. So I have on a D folder, on the hard drive, or actually a partition, I have made a GitHub subfolder, which is just a generic name. It could be anything. My cool projects, it could be a name, right? And then I have multiple projects, mine, somebody else's, and each is its own repository, each standalone project. So we have it. Where do we go it right now? BSD, right? B, right? So we have it here, right? So that's where the data lives, right? Again, the structure, the D on the GitHub, this is completely up to you where you want to store your data, right? Your projects, right? But you can see here how the structure is same here, right? Explorer, that's same as the Windows Explorer. If you're using Mac, how many Mac users here? One Mac user. Okay, same thing, right? You're using Finder, right? Same idea. So hopefully everybody can see the structure, understand the structure, right? And we have, for this workshop, we have a notebooks folder. Again, it's not required, but I usually I call it notebooks. You could say my books or Jupyter if you want, I don't know, something else, but it's usually called notebooks. And I also have data folder. Slight note, you might notice there's also some nice icons right here. Right, this is another extension. This is completely cosmetic. It's called Material Design, right? Material Icon Team by Philip Keefe, right? And This is, if you search for it, right, it's an extension for Visual Studio Code, and it gives basically nice icons for different type of files. If you notice here, text files have an icon, README files, license has an icon, and folders have icons too, right? So if you call them a certain way, right? So I noticed actually it used to be that notebooks did not have this icon. I think last year I don't think there was an icon. So apparently this designer, the guy who works on these icons, he decided that notebooks is now established enough that it actually is worthy of an icon, I think. Right, so yeah, okay. But that's just completely cosmetic, right? Obviously you don't need to see the icon. So now here inside, let's look at what we have here, right? So we have day 1, part 1, IPyNB, right? So IPyNB actually originally stands for Interactive Python Notebook originally, right? And now these days we call it Jupyter notebooks, right? So, so Jupyter stands for what? Who knows? Who knows what Jupyter stands for? On R. Yeah, so 3 languages actually. So the notebooks are not just for Python. You could write your Julia code in it. Of course, you have to install your Julia or R. And actually, that's not the end. You could actually write your code in some other language, even C++ or Scala or some other language. You could technically, if you set up correctly, you could use notebooks to write code in pretty much any language. But it's mostly Python these days. I would say 80%, maybe some Julia users, maybe some R users, but they have their own IDEs, right? So it's mostly Python, but you could use for anything else, right? So, okay. So again, though for those who are new to notebooks, right, I'm going to close this here, this Explorer, so you can see all of this, right? So the key part of notebooks is that it's 2 types of cells, mainly, right? You have code and markdown. So markdown cells are just for us humans, meaning it's for displaying, for structuring our content. It's basically a way of writing, well, basically web content actually. Really underneath these notebooks they are basically web pages, slightly fancy web pages actually, right? But what you write is, you write something called markdown, right? So markdown, I'm sure some of you are familiar with markdown. What's markdown? Markdown is a way of doing what? MD files. Yes, exactly. It's a simple way of structuring text. So from today, I would recommend GitHub Markdown guide. I wish I had a chat here. Actually, I could give you Markdown guide. You can just, yeah, internet is kind of slow, but it's a very simple way of writing. You can spend about 20 minutes, and it will pay off for, I think, for years to come, because I guess I'll show you from my own, right? So notice, right? So you have a hash mark. So what does hash mark stand for in this case? Yeah, it's a header. It's a first level header, right? So I could do this, right? Main site, main banner, right? And this would be a second level header, right? Right? Main banner, right? And of course, and so on. And you notice here there's an exclam, what you call this picture, your site, and you have a GIF or JPEG or PNG or some file, and you can display it on your site, right? So notice also this is an external site, not maybe the best practice. You should probably host your files locally, because I think most files, if they decide they don't like you, they could put some, I don't know, some ugly, dirty pictures here actually. So you should not really generally do this, right? So, and let's see, the guide is, oh yeah, here you go. So this is the article. Again, not part of this course, but I would give you some pointers, right? But if you're writing Jupyter, eventually you will be writing Markdown, basically. And again, why write Markdown? Okay, here we go. Where is my Markdown? Oh, this is not what I wanted. Yeah, GitHub. Let me see here why this is general. Yeah. Oh, here you go. On Markdown, I don't know if there's a special Yeah, there's a way of doing some other, here's this, here I think is, every company, every organization has a slightly different, maybe standard of markdown, but here you can see, this is the basic one, right? So you have the headings. What else do you need to know? You have bold, double stars, italic, 1 star, strike through. You can have nested, right? Bold, italic, subscripts, those are less used. Quoting text, and also you will have links, right? Something like this. You want links and pictures, images, like what I was using here, right? This is the image, and also you will have lists, right? You have type of, these are bullet points, right? Bullet point lists or numeric lists, right? Those are your core ways of structuring text, and you can go pretty far. So Markdown is then converted to HTML, to website, web technologies, and you don't have to write HTML by hand. I mean, you could if you want, but that will be quite take longer. That's why we're using Markdown, right? You write Markdown and you get a pretty nice outcomes, basically HTML, which you don't really see, but you see here. So here, okay, so you can also see this notebook, right? I click on it. Notice here, right? So I have the second level header, third level header, and now you see my links to me, right? So that's a link, right? You have the brackets, square brackets, and you have a regular parenthesis, and also links to these, basically, right? So that's how you can do it. The third level, fourth level, and you have bullet points, and it's very, very quick way of organizing, structuring your whatever content you're doing. Okay, so that's enough of Markdown. And then you have, of course, the second type of cells, right, which are, of course, code. And that's where, meaning these will be sent to some language, your programming language server, either locally or somewhere externally, and it will actually run the instructions, basically, right? Run the code, right? So, again, you can see also here how I did this, right? Again, picture, right? I put a link to the notebook, right? And you can see how you can write nice, there's a link to the picture, and there's also a link. So that's how I generate these links to these external notebooks, right? So, now Copilot, right? All these links again. And now finally we get to text analysis, but I was going to hopefully get to the code actually, right? Maybe we'll get to the code, hopefully, but maybe I guess, yeah. So code cells, maybe I can show you before we move on to text analysis, right? So I will do a code cell, and I will do a hello world, right? Print hello BSSDH 24. Right? And so basically this instruction gets sent, in this case, to my local server, right? And it runs, right? The key part to remember is that whatever instructions you run, for the duration of your session, the memory stays active, right? So you all know what variables are. So variables, the data, stay in memory unless you restart, right? So unless you restart the kernel, right, then you lose all the memory, right? So that's one of the things. That's why if we are working some sort of analysis setting, right, text analysis, data, any kind of analysis, we are exploratory, right? It's much better workflow. If you are like working like traditional programmers, you would write the code, you run it, and then the memory is gone, right? So this interactive, that's why Jupyter notebooks are very popular among data scientists, machine learning, when you are exploring different models, also, again, for working with text in general, right? So that's a key point, right? So memory, and I'll put, let's say, a name is Valdis, right? Right, and print name. So notice also, Copilot is going to be slow. I'll have to do a lot of work today, unfortunately, or AI assistants will be lagging. I was hoping AI would write the greeting for me. Greetings, right? And usually, if I had a good connection here, you see this spinning, right? So the connection to OpenAI is kind of slow today. So I'll have to do it myself, of course, right? But this is not the end of the world. Right, so of course, greetings, right? But AI has better spellings than me, right? So yeah, of course, getting Valdis. So again, notice if you open up here Jupyter for Visual Studio Code, right? You notice here, right, that there's a variable name, right? Name type string, size 6 because 6 letters, right? And value Valdis. If you are using Copilot, right? Here, right? I'll connect. I think I lost my connection. Right, I'll connect. It should be same. Any place, like I mean, I could put. You can remember you can put code cell any place. So name is Valdis, right? On print, right? F. Welcome to BSSDH, right? Right. So, okay. And now, if I run this, yeah, okay, I run it anyways. On Valdis is here, and if you click here, X, right? Variables, same thing, right? Name, string, 6 characters, and if you press, this is a Google's version of Jupyter Notebooks, right? So you get the same approach, right? You can see what you have in memory, right? Very, very useful, right? So again, I'll be using this locally. It's faster than Copilot, than the Colab, right? But yeah, so if you have, sometimes you have a lot of variables, you have a lot of data, right? This could be a way of quickly looking up what you have, right? So if I restart, of course, it will go away, right? But now it will stay around. Okay. Now let's go back to I'll minimize this a little bit, right? So our main, or now we move on to. We'll be moving on to our main, or like the content of what we're going to be doing. But now, before we go on, so again, so any questions on the technical part? Maybe what's happening with the local cloud? Do you have any questions on a Zoom? Everybody's. So how many are present? I don't see how many present on a Zoom remotely. 13. Okay, and I have 1, 2, 3, 4, 5, 8, 7, 8. 8. So 21. Very good. Good turnout, actually. It's about ideal class size. About 20 is good size. So, all right. So we can move on because we have a lot of material to cover. So text analysis. I'm sure most of you have taken some courses which relate to this topic, right? But we are basically are going to be transforming some unstructured or structured differently text into structured data for our needs, for analysis. Maybe we want to determine some patterns, do some statistical analysis, maybe we do some visualization, right? So the related concepts are text mining, text analytics, data mining, right? So why is it important? Of course, because, well, we want to get the meaning, right? What's behind our data or corpuses or documents, right? Also, these days, as we are drowning in amount of data, right? If you have 100 documents to analyze, you could probably do it yourself, maybe 100 articles, right? But you have to analyze 10,000 articles of something from some publication. You're not going to be able to do it yourself. Right, you could hire a team of assistants, right? But still, let's make a computer do the dirty work for us, right? So, and of course, if you have 100,000 or million document corpuses, or even I think what's our highest was 100 something. No, I think artists. What's our highest document count? Was it? Yeah, biggest corpus. 50 million? I think it was 50 million something. Not again, I would almost say not big data, but decently sized data, I would say, right? There's a term called big data, but I say big data is whatever does not fit on your own computer, right? That's what I call big data, right? So, but yeah, so we have a lot of data to process on, again, we're going to extract some meaning. So afterwards, of course, there's discourse analysis. We study language, text, and context. Right? There's different ways of analyzing. But main thing is the first step, of course, is actually getting the data. And that's what we're going to be focusing in today's early part, actually, how do we access this data, and how do we extract this structure, right? So, again, maybe you want to run some fancy machine learning algorithms afterwards, and again, you still need to prepare it in a certain way, right? Building fancy models is usually not that hard, actually, as long as you have prepared the data correctly in the correct format, right? So correct features, right? Again, as I say, garbage in, garbage out. If you give it some, just throw some data at the model. Well, don't expect miracles out, right? Right. So again, you can read this at your leisure afterwards. But yeah, so. We will want to look at some modeling, but that's mostly for tomorrow, or plan of attack, right? So we want to get some data from some source, and so what ways of getting data we have? Usually it's going to be some sort of web-based source. Maybe it could be a database. Maybe somebody gives you a file, right? Gives you a zip drive, right? But we will be using a file. This time we're going to get a file, right? What's a file? Basically just a way of specifically structured way of data, right? Sequentially, right? At least logically sequentially. But we will need to prepare it, right? So our first goal will be to read the data into a pandas data frame. So who has used pandas here? 1, 2, 3, so, yes. Some of you a little bit, right? So pandas is a library for Python, and it's basically, as I say, Excel on steroids, basically, right? So it's a way of manipulating a much larger amount of rows of data than in Excel. For those who have used Excel, if you get like couple 50, 100,000 rows, it's going to get kind of slow, right? So, Pandas offers a way of working on much larger data sets, basically, right? And of course, on the downside, it's only you need to know some bit of Python and you need to know a little bit of Pandas, right? Approach, basically, right? So quite popular. Of course, if you have some really huge data sets, there's some things like Apache Spark, but these are beyond of this workshop, right? But we're not gonna, for now, we just have a file. Let's assume we just have files somewhere, right? And then, of course, we will need to clean these files, right? You'll probably need to clean up punctuation, numbers, some non-textual characters, things like that, maybe stop words, again. And then we will want to extract some features, right? Maybe we'll tokenize, right? Split the document in the words. Again, we'll be talking, of course, today. We're going to be working, we are humanities here, so we'll be working with textual documents, right? And maybe we'll want to do some stemming, some lemmatization, right? Getting the roots of the words, right? Maybe we want to also assign some part of speech tagging, of course. And then we will want to do, again, this is for tomorrow, or maybe very late today, creating embeddings. Meaning, what's an embedding? Basically, you have some sort of, could be a word, could be a sentence, could be a document, could be maybe something longer, but you assign it some numerical values. Generally, these are so-called floating point values, meaning usually from 0 to 1, you have a vector. What's a vector? It's just a bunch of numbers, basically, right? Very roughly speaking, right? And that's what's an embedding, right? Because why? Why do you need these embeddings? Of course, for machine learning models, different models, for the algorithms, they want numbers. Computers don't like words, right? Because behind every word, behind every character, there is a number, actually, right? So, yeah. So that will be modeling. And then, of course, hopefully tomorrow we'll get also to some visualization, maybe some more extensive visualization. Topic modeling, maybe, right, if you have time. So, I didn't get to the main part, right? So for yourself, right? So tomorrow afternoon, the last part of lecture will be, if you are here for gaining some credits, you will basically you'll need to get your own data and do some processing, maybe some modeling, up to you. How much? Not very much, actually, right? How much time you have. You'll be able to do this during the class. And then finish, if you want, you can do it in the evening, maybe. Again, depends how much you want to do. There's actually, I think you already sent a link to the Google Forms where to submit, right? Do you guys get it yet? I have the link here somewhere actually on the last day, but there will be a link to Google Forms. You basically will upload a notebook of your own, right? So for those who will be working on Colab, right, remember, you can always download the notebook here, right? Because what's the bad side about the Colab is if you go away for the lunch break, right, it will probably shut down the instance, right? Google is, depending on the time of the day, Google will stop maybe usually 30 minutes, usually, roughly. So meaning your data you're working on, right, it might stop the notebook, basically. So you should want to, regularly, you should download or save, or you can also save copy in a drive, but for submission, you'll just want to download IPNB and submit it. So that's really your submission for this course, if you want credit. If you don't want credit, you can still submit, right? It's fine, right? To gain credit for this course. Okay, but we'll talk about that tomorrow for the actual technical issues. So let's move on to data collection, right? So web pages, right? This week there was actually, do we have a workshop on web scraping this year? I guess not. We had one last year. Very popular concept, actually, on web pages, because you have some text on a web page, you need to get some data out of it. Social media, you know, Twitter, of course, or X now, right? I should say X here, right? X, right? Issue, for example, about 10 years ago, it was really easy to get data out of Twitter. Now, you have to pay quite a bit of money to Elon Musk, right? So to get some data, right? And then you have to almost beg for it, right? So some social networks are relatively open, some are not, right? Again, books, of course, Project Gutenberg is one of the sources, but there are other sources, of course, your local library sources or university sources, right? Again, the general idea is that the best way is you have an API. What's API? Application Programming Interface, right? Meaning it's a way of structured way of accessing data, sort of organized, right? Not always, right? But again, for this workshop, we'll mostly be focusing on files, right? Make things easier, right? So Clarin, for example, who knows Clarin? Some of you know Clarin, right? So it's a research infrastructure, right? Different, it's not just one thing, it's just a different federated, meaning different centers, right? Pooling their resources, right? So Clarin offers some data sets, and we will be working with Old Bailey corpus, right? Which is about 130 million words from criminal court in London, right? Again, here at the library we work on Latvian corpuses usually, but since we are multinational audience here, so we'll be using the English one. So if you want to go here, right, you can go link to Clarin. Let me see here. Actually, by the way, I think I click Control Center. Yeah, Control, I think, yeah. Yeah, it will open up, right? I think it still should be, let's double check if there's no link rot. It's a big problem on the internet, right? Link rot, meaning links go away sometimes. But assuming, yeah. It should be fine. I mean, they should, again. But yeah, but of course, for the workshop, it would slow us down if you actually download everything, 130 million, right? The full corpus. It would be just introduce some additional processing time. So what I did is made a small sub-corpus of this, right? A selection from here, right? So official license for this is Open Creative Commons. You could get it, right? But we will use about, I think, about 1/10 of it, roughly, right? So how do we get data? Some considerations. Again, there's wide variety of formats, right? I mean, we have textual formats, you know, text or Markdown maybe HTML. For this one will be a medium difficulty, intermediate difficulty. We'll be using XML. So which is actually, it could get quite painful sometimes. Who has worked XML, right? Some of you have used XML, right? And XML is very established format, and it's extremely customizable, meaning you can write your own, how should I say, tags. You can modify it for your needs, right? to your own, your own domain, basically, right? So what we'll be using, right? How Clarin offers this, right? It gives you something called but we will actually get to we'll get to coding first. Let me see what I have here. Right. So XML format, about 3 megabytes compressed, 17 uncompressed. So what we'll be doing is we'll need to download the data. We'll need to unzip potentially data, right? Yeah. So what we'll be doing is we could of course do this some of it by hand, right? Click, download, unzip. We could do this, but we will be using Python for this actually. So because maybe in the future you have a huge list of files you want to download and unzip. You don't want to do it by hand, right? Just a little things you want to make your life easier, right? So we'll be using something called Python library requests. So some good practices before we continue, right? So I already touched on markdown cells, right? You should strive to write in markdown. You should strive to write what you're doing. Also, if you are doing, notice here, right? If you're using these headings, it's a very good practice to use headings, because what you get is you get text at TOC, right? You get a nice outline for free, basically, right? You can even generate a small book out of it if you really want to, right? So you get nice structured you have nice bookmarks, you can jump, right? Welcome, you can jump through to different sections, right? Here, also if you are in a Colab, it's the same thing, right? Here, right? Table of contents, right? You can jump here, right? Some good practices, right? And again, you get this structure by using markdown cells, and you have these hash marks indicating the level of heading, right? Very painless, I think, right? And you get nice structure for free, basically. Almost free. All right. So you with me so far? Okay. So we're ready to actually do some coding, actually, hopefully, right? So let me now go Copilot install. Okay, AI pipeline, data creation into text analysis, on data connection. So Clarin, right? And what else do we have here? Old Bailey, right? My favorite corpus, right? Not my favorite, but actually a pretty decent corpus, actually, right? So some good practices. Here we are. Okay. Right. All right. Now, all right. So, what else? Some good practices in general, ideas, right? So headings, of course, also in the code cells, right? Code cells are Python cells, right? Write comments. So we use hash marks for comments, of course, in Python, right? Also a good thing to do. Why? The main thing is, of course, to write why you're doing something. If you're saying print hello world, you probably don't want to say, okay, I'm printing a hello world. That's kind of not much point. You say, why are you printing hello world? Maybe you have some way of greeting. There might be a reason for this. I'm sure there's a reason why you're greeting someone, right? So again, if you're learning something, it's completely fine to write maybe too many comments, right? I really hate when students submit me works. They are nice code, but there's almost no comments, right? And they think I'll be able to figure out their way of thinking. Like, remember, don't make the teacher think, right? That's the core idea, right? And it's approach in general in life as well, right? For design and everything, right? You don't want to put extra difficulty. Don't make life more difficult than it should be, right? So commenting, very important, right? Also, of course, descriptive variable names, right? XA, ABC, usually not a good name, right? You want to usually write what your name things what they are about. Another funny story about this, I had a student who submitted the homework with cat names. All the variables were named of the cats, right? But the homework had nothing to do with cats, right? So I told them, it's a nice approach, but what does this fluffy mean? I mean, how am I supposed to figure out, right? So if you're doing for a wider audience, of course, if you're doing for yourself, you think you'll remember which cat was what, right? Okay, but again, so that's one thing is if you want to progress in your approach, right? Write descriptive names, right? File names, same goes for file names, same goes for folder names as well, right? Again, Git is a version control, so who knows who's using Git here? 1, 2, right? 3, 4, so yes, of course. So Git is basically bookkeeping for your code, right? Again, this will be a nice workshop just on Git, so I will not cover Git in here today, but very well suited for textual format, meaning if you have some text changing, right, to track the differences on programming is, of course, mostly just text, right? So it's great for that, right? But it's not ideal for notebooks, for example. That's one of the downsides of notebooks, because notebooks, IPyNB, actually underneath, they are JSON files, actually. But, you know, a little secret, right? And who knows JSON, right? You guys know JSON a little bit, right? So yeah, so it's not the change if you're doing some backup, for example, for notebooks, right? The JSON format also might not be, it's not great, right? But okay, right, so some good practices. So notebook, one of the things which all of us who are using notebooks are guilty of not following is notebook should be able to run. If you press run all, it should run through. That's your goal, right? If I press run all, it should run through without errors. When we are working interactively, when we are trying things, that's not always the case. We are doing something, we figure out something. That's what's good about notebooks. You can try things, right? But in the process, of course, you might break the flow, right, out of normal programming flow, or instruction flow, right? Because notebooks, you can try things multiple times. Maybe your variables, because in notebooks, your variables continue living, and you can run a cell even before the variable was declared. If you do it, that's one of the downsides of notebooks, because you have a kind of free flow, right? But you should strive to have a top down, right? A nice flow, so you can run all, right? That should be the goal. Again, especially if you're doing something for submission, right? For somebody else who's going to be working on it, right? So, okay, it's a fusion of logical creative process, but you don't know what's going to happen at the end, right? So finally, we still have half an hour for this session, right? We finally get to some real coding, right? So, in Python, of course, this will be up top, right? The first cell, we are going to be importing, of course, the libraries, right? That's a good practice. So generally we import the standard libraries first, meaning what's standard library? That's one comes with Python, right? So system, for example, I like to print a Python version. Again, this is obviously not required, but it's good to know what version of Python you were using, right? So you can use this version, and it will tell you what Python version it is. What else we'll be using? We will want the pass module from passlib to work with pass. So from passlib, import pass. This is also standard library. Just notice this part here, right? So I'm not importing the whole passlib library. You know, I'm just one sub module, basically pass module, right? This is for working with folders, files. This is a new way of working. There's some other older libraries, which OS ones, which you can also use, but pass is a new way forward. And also, since we'll be not working, right? Forking with zip files, we will need a zip file, right? So, on now comes the painful part is we'll be working, since to make things a little bit more difficult, we'll be working XML. So Python comes with XML parser, right? A way of extracting the structure from XML files. So we'll be importing XML E3 element 3, but that's a handful, right? That's 3 words. So what we are doing, also very common in Python, I am importing it as a abbreviation, ET, right? ET come home, phone home, right? So XML element 3 as ET, right? So just the one module, right? And maybe we'll need some regular expression. So who has used regular expressions? A bunch of you, right? For text extraction. So how do you feel about regular expressions? Yeah, power, right. But there's a story with regular expressions. It's too much power sometimes, right? So you can go pretty deep, right? Regular expressions can get quite hairy, but so maybe we'll use a little bit of it, right? And also maybe we'll want to do some JSON. We'll work with some JSON data maybe. And so also it's a sub-module of, it's part of library. And again, Python includes all of this with the standard installation, but again, we import it because on a need to have basis, basically. Also, we install, we are going to also lose maybe some datetime. Again, why do I use datetime? I usually like to do some date timestamps. Again, just to know when the work happened. Sometimes also may be useful for file naming. You add some date stamps maybe, right? Again, this is part of standard library. And this is one of the things of Python, where Python slightly, I think, didn't do a good job of naming. Even language designers do sometimes bad. It doesn't do a good job because it has a datetime library, right? Module, right? And it has a datetime class underneath, right? So it's datetime technically, right? So it's kind of pain to write. So that's why I import only sub-module of this class actually. So. Okay, and now maybe we'll do some random, we need some random things to do, right? Some random selections maybe of data. So that's include random, that's also standard library. And now we get to external libraries. Again, the order should not be important, but it's generally good practice to import the standard stuff first and then the external libraries afterwards, right? So these are libraries which might not be included in your installation, right? So I like TQDM. TQDM is really tiny library for progress bars. Absolutely not required, but it's included in a Google Colab includes installation, right? Very easy. And of course, you'll want also requests. Requests is one of the most widely used libraries for making requests to web resources. It could be also include some authentication, cookies, all kinds of good stuff, right? On pandas, right? So pandas has a very common convention. Import pandas as PD, right? Again, this is pretty much standard. Again, why? Because we are lazy. We don't want to write pandas something all the time, right? We just write PD, right? That's simpler. But again, so two-letter abbreviations are very common. So most popular libraries have their own two-letter abbreviations. I mean, nothing will happen if you say my pandas. You could rename something else, but it'd be kind of useless, right? You make it longer, you could, right? So use common conventions. That's what I was going to say, right? And one more tip: most external libraries, when you import them, they will have a version variable, right? This is kind of internal variable. Most good libraries have them, right? And you can check on the version in your Python code, right? So let's run this cell. So we have our Python. We should see what? We should see the Python version, right? And we should see the pandas version. Let's take a look. Let's see if this works. Yeah. So Python 3.12 for me. And pandas version should be 2.22. It's not the latest. I don't think it's on this computer. I don't think I have the latest one. If you run this cell on Colab. Let's see, where do we have here? Yeah, here. Fine, let's run it on Colab. We'll run. And we can compare it. 310 and 203, right? So pandas, so Google is about 2 versions back, as we mentioned already, right? Right. Okay. Yeah. Okay. You might be asking why is Google so conservative? Because of course they want absolute stability, right? So everybody so far, locally or globally, code runs, right? Excellent, right? You have your pandas. We have our Python. We have requests, right? Yeah. Now we have the file, right? And again, we could just go to this data map, right? I could show you where the data lives. And I made it locally, right? So we got data. No, not here. Main data. So here is a workshop data subfolder. and I think it's a zip file, Old Bailey sample, this one here, right, the zip file, right? And if you click here, right, actually it's going to try downloading it, right? Actually, it will download here if you click on it, right? But we want to do it with our program. No, here, right? So here, view raw, right? It's too big, it's a zip file. You could download here, right, with save link, right? But we are going to be doing this as with a program, right? So, right. So first step is, of course, know where the data lives. So you need the URL, right? And I'm going to print the URL. URL is here, right? And you can see it's Jupyter. Do I have my name still there? I think I didn't restart it. Let's take a look here. Maybe oh, here. Where's my variables? Where's my? No, I have problems going up. Oh, here you go. Right. So yeah, I have my name variable. It's a string, and I have URL, which is just a string. It's just a string, right? So. And of course, I could click here and I could download myself onto my computer. Right. So, but now we will want to download this data into some folder, right? You don't have to, of course, download data in a folder. You could just download directly in the current folder, but I'll show you some recipes how to make a folder, right? So, we can find where we are, right? This is just see where we are currently. And then we have a make dir, right, instruction, right, which will create a directory if it does not exist, right? So let's take a look, and then we can check whether it exists. So this is just a tiny recipe, right? We are here right now, and we actually, in this case, we created folder temp folder, right? Again, notice how on Visual Studio Code, this material design has an icon for temp folders. This is also a standard naming. Temp means something you want to eventually delete. So if you run it here on a Colab, right, it should happen as well, right? I have it here, I hope. Remember, one of the most common errors in notebooks is you forget to run some cell, right? And then you don't have some data, and then you see why it's not working, right? So again, just if it's not working, check if you have all the cells run right now. So if you check here, Colab does not have a temp folder, so let's make one, right? Right? Yeah, so true, and now you have to refresh, I think, yeah. Yeah, you see temp folder is created, right? So again, so make dir exist, okay, so meaning is if it exists, you don't want an error if it exists, right? So notice how current work, so you made it from a current directory, you made a new subfolder, a new subdirectory, okay. Again, of course, you could do this by hand, of course, right click, and so on, of course, right? So now we are finally to download the data, finally, right? And we'll be using something called get request. What's a get request? It's something we use on our web browsers every time we go to some web page. If you just look at the web page, usually it's going to be a get request. There's also post requests and other ones, but get is the most common request, right? So, on stream, right? So to make things slightly more interesting, not interesting, but more useful, right? If it's a tiny file, we know it's going to just download instantly. You don't have any problems whatsoever, right? But if it's a bigger file, you might need to add some extra, how should I say, parameters, some extra settings to make the download go smoother, right? And also, so here are some considerations, right? Some for this recipe. We want to have stream of data coming in. Also, since we don't know what type of data we are downloading, we're going to copy the data exactly as it is, binary, right? Zip files are binary, meaning they're not humanly readable, right? So because later on we'll want to, so basically want to preserve exactly as it is, right? And we have temp, right? TQM. We're going to have also use TQDM for progress bar, right? So this recipe will work also on very big files, right? Because we're going to be downloading the file in chunks, right? Otherwise, if you didn't do this recipe, just use a very short recipe, just like maybe get something, it might be the download just gets stuck somewhere, right? Basically, it won't be, it will be too much to chew through. So let's see what else. So about this recipe, first of all, we'll be getting the name of the or URL, right? Where's or here, right? So basically, just a tiny trick. We know that the file name is this, right? So what we do is we use split by a forward slash, and we get the last item, right? Simple thing. So we want to get this, right? Obviously, we could write this by hand, right? But we actually get the file automatically, right? That's a file name we want to save, right? Now this recipe is how you could download larger files. There are some other recipes, but this will work it should work quite well. And let's explore this a little bit more detail, because now we finally have some Python code, which is maybe not as trivial. So we are opening some file name, right, in binary mode, meaning we open up, but we don't have any data inside, right? We actually open a stream of data, right? Right. So now we may make a request, right, in a stream mode, right? And as I think we had 10-second timeout, right? So if our internet is going to be very slow, it's going to be, it might stop, but let's see. And then we get chunks. We get these 1 kilobyte chunks, and actually it will work quite quickly. And then for each chunk, we write to the stream, right? And we update the progress bar, right? And what else? And yeah, if we have if there's some issue with download, we will maybe raise an error. So let's take a look. When I tested, of course, on a good connection, I got 8 megabytes a second. Not maybe great, but it should be okay. Let's see what happens here. We'll see how slow our internet is here, right? So this is a big test. See what happens. We'll save. Maybe we'll get timeout. I'll have to use a collab meanwhile. And of course, everybody's downloading it. All 20 of us are downloading from GitHub, but GitHub should be able to handle it. I hope Microsoft can handle it, right, after all the problems, right? They should be able to handle it. We'll see. Yeah, it was about a sec. Yes, you see, timeout error. We got a timeout error. So this means actually this connection is too slow. Actually, I do have the file here, but let's see what happens with from the Google Colab, right? Let's do it from the Colab. It should be faster. Yeah, it's almost instant. Yeah, so 2.9. If you're doing it from the Colab, right? Not from our library, not from here, right? Our speed, it should be down. Okay, no, it should be going quicker. Yeah, 13 megabytes a second, almost instant, right? So let's check. Let's reverse. Well, it should be here, right? Oh, yeah, there it is. Okay, yeah. So it's down. If you're using Colab, the Google version, it should be downloaded here, right? Locally, if you're here, let's try it again, right? So basically, we had a timeout. I could, of course, offer more time. If you try and download some really long, all bad connection, right, like right now, I think I could do timeout 20. Yeah, I could increase the timeout, like, of course, it's parameters, depending on the library, right? You have some extra parameters where you want to maybe play around with that. Let's try it again. Unfortunately, we'll save, right? Okay, it's starting, right? It got the first chunk, it looks like, right? But very, very slow. Very, very slow. Luckily, I only have it. Luckily, I downloaded it yesterday. So, but this, of course, unfortunately, is the issue of this network connection, unfortunately. Right, yeah. So we got a timeout error again. I could handle this error, right? But in this case, I mean, I could say ignore the error, but obviously I don't want to ignore the error because then, I mean, the file is corrupted then anyways, right? So you get timeout error, right? So did anybody locally download the file? You got it. You all got it. So it's only me who is a bad connection. Yeah. Excuse me? Yes. Yes. I remember this very well, right? So, okay. But yeah, so I have it already. So on a Colab, of course, you should be able to, get it. So Google made connection to Microsoft servers. Here, I am not having so much luck, but luckily I have it, right? So, not that one, but I have it in temp folder, right? I have it here somewhere, right? So maybe something has some issue. So this is what we downloaded, this one here, right? There's some other files which we don't have, which we're gonna get to later. But, so we download this. right? Right. So, by the way, if you get these errors, usually, how should you handle these type of errors, right? It looks scary, this wall of text. No, don't worry about it. You start here, right? Either start at the top, very top, or also very bottom, right? Read timed out. So basically, the request actually was timed out for some reason. Either my Wi-Fi is not working very well, or actually, like I said, it doesn't like this Wi-Fi, but it timed out, right? So, but let's check. Okay, but again, let's check if the file is there, right? So I have a name of the file, right? You can look at if I have. I have some file name is this old Bailey sample 123, right? So I am going to check. Oh, I don't have it? Oh, I know what happened. I overwrote it. Okay, but that's not the end of the world. What can I do with this? Well, let's check out source control. But actually, that's going to be, yeah, right now that is bad news. So, right, what happened is this, right? Since I was starting a new connection, right? Let me show you. I started download, right? I overwrote the old file with a blank file, right? Because it was already there, right? So, but I have to open up a file handler, right? So then, when I was downloading, of course, I didn't download anything. So I have a file, unfortunately, it's zero size, right? Again, it's not the end of the world. I should be able, I'll just copy it from the last years, right? It should be fine. I'll do it by hand since it'll be quicker, right? I'll go here, data, not here. Is it zip? Yeah, this one here, right? I'll just Control C, right? Good old Control C, and Control V, right? But I'll put it here, notebooks and temp, right? So let's check. Yeah, indeed, you see, 0, right? So I'll copy over, replace the file and destination, and I have full size. Now, I should be able to see the full size, the correct size. Let's check. It's also good to have some issues sometimes, right? Because again, it's good to not to worry about them. They're pretty much always solvable in some way, right? So yeah, you see now the file size is there, right? So we are good to go, right? Yeah. Print file size of original temp file name. Let's see what's happening here. Will it work on Colab? I think so. File part. Oh, it's also lost connection here as well. Yeah, because of course I have to connect to the notebook, right? Yeah. It might have lost connection. I hope I didn't open two places. No, yeah, okay. So and now, so we have the file. This is before the break. If you really, sometimes you are downloading something which is very crucial. You might have seen this if you're downloading, for example, Windows images or some images, right? Sometimes they will offer you a hash. What's a hash? It's a digital signal. It's a checksum, basically, for file. And you can use, if you see this hash, you can check whether this file is actually what it is. The idea is this, that each file gets a unique, well, with an extremely low probability of a collision of having the same hash value as another file. So it's just a bunch of numbers usually, right? Something like this. This is MD5, not to be used for secure, but good enough for checking file if they are same, right? Meaning you have two files. If somebody changes a single letter, you'll have a different signature, right? So you know, okay, the author told you, here's a big file, download it. But here's hash, just to check, right? If the hash doesn't match, this means something went wrong during download maybe, right? So let's double check. So of course here I'll be checking, okay, I'll check it CF658, let's check, right? And it is still 658, right? Of course I shall check everything here, right? So this is just an optional way. I'll just show you Python includes this hash lib here. Right, so and you can generate. There are also other SHA256, SHA1, right? Different ways, But that's something you sometimes see this, right? If your data is very important, right? So you can double check, right? So we have our data, and we want to start working. So what we'll want to do is unzip, of course, right? So again, we could of course use our built-in OS unzip functions, right, by hand. But again, imagine you have many files you have to unzip, right? And then writing a program will be much better, right? So we'll make a zip pass, right? On that's our file name, right? Also, I'll make some assert file exists. Yeah, unfortunately, even Copilot since Copilot depends on a connection, it is not giving me assistance. Yeah. Assert file exists. And if Copilot was working correctly, this would be great, but unfortunately it's not. So there's a way of writing here. Yeah, assert zip pass and exists. I think exists. Yeah, exists. No such file. I have to do this by hand. Usually AI assistants would do this for me. Basically, what's assertion? It's a way of saying, okay, this is true or not. If it's not true, raise an error and say, okay, no such file, right? Some custom error, right? Whatever error you want, right? So I like if you're writing a longer notebook, it's good to sprinkle some assertions, meaning to sort of like test your whether you are still on the right page, so to say, right? So sometimes, especially if you're going to be making it so it can run from top to bottom, right? So it's basically sort of like a checkbox or like okay, is this, are my idea of what should be happening, is it still true, right? So here I'm saying, okay, does this actually file exist, right? Of course, it's not crucial here because you will still get an error if you try to do something, right? So what I'm doing is I'm saying, okay, here's the file name, right? Does it exist, right? Exists, right? Yeah. Yeah. It checks whether there's it returns true or false, whether the file exists. Okay, we're going to unzip it, and then we're going to unzip in the same folder, and we're going to zip to unzip folder. Okay. All right, so let's take a look. So these are just preparations before the break. And now let's unzip our file. So again, tiny recipe. So you have a zip file, and it's really easy. You have you open up, you have some way, you know where this is where the zip file lives, right? This one here, right? This part here, right? Again, it will be different on your computer, be something different on a Colab. And you say extract all, and where do you want to extract? Really easy. If you've never done this, it's really easy to simple recipe, right? There again, for truly large files, we'll be taking a break in 1 minute to get this working. So for truly large files, there's some other more complicated recipes, so they can stop in the middle. But for this one, it should work fine. Let's take a look. Let's run it if it works. 0.1 seconds, notice, right? And let's check. And I should have some bunch of files, right? OBC text, yes. And there we are, right? So what happened is we unzipped the file. It's a temp file. But if you check our temp file here, if I do it by the hand, regular, there's OBC texts, right? So Python automatically created a subfolder, OBC texts, and extracted everything, right? So simple recipe, and now we should have our data, right? We can take a look at this scary looking XML, and that's what we'll be working in about 10 minutes. So let's take a short break, about 10 minutes, coffee break, if there's still any coffee left, I hope, right? So any questions so far? Right, so hopefully by now, like I said, hopefully you have better connection than I am. Those on Colab should have no problems. And after the break, we will look at XML. Where are we? We basically went to a file location. We downloaded the file, and we unzipped it using our own notebook or Python code, right? So let's explore this. Right? Of course, we already saw this in a map, in our temporary map. So we see these files, right? These are a whole bunch of XML files. All right. But let's do this as using our notebook, all right? So here's another recipe to see what's inside. So for file in our unzip folder, right? And we'll check whether it's a directory or whether it's a file. We will print it, basically. A very simple recipe to explore what's there. Right, so you see a file, directory, file, 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 directory, right? So, oh, no, there's only one subdirectory, right? So that is in here, right? We explored this folder, but we didn't go deeper, right? We didn't go to the deeper. So if you don't know how deep the rabbit hole goes, right? So you want to use recursive glob. So what this means is we say, okay, go through our file structure as deep as needed, base maybe 5 subfolders deep, get me everything, right? So we use a R glob, and what does the asterisk means? Means it's basically a joker, a wildcard. Basically, give me everything, right? I'm sure you're all familiar with using your Finder, your Explorer to search for files, right? So wildcard, we want any files, right? Let's take a look. So we are searching for all the files recursively, and I will be using so-called list comprehension. Okay, let's add how should I say? Let's add the power to our network connection. Maybe this will work. Hopefully it can. Yeah, great. So let's take a look. So it will list. We have 28 files in our list of files. I printed the first 10, right? As you all know from Python lists, I use :10, so get the first 10 files. There's another little trick here, is that printing trick. Again, this little star. What does this little star mean here? Asterisk here. Basically, I unpacked a list and I just gave them separately, one by one. For the printing, so for the print, I gave it separately, not just a one list of files, but separately. And I said, okay, since I want them in a new line, I added separator. By default would be comma or white space. I think it's white space, right? So I gave it a new line, so this prints them all in one line. So this is a simple recipe. Now, next one, okay, you say, okay, but I don't need the CSV, I don't need the HTML, I want just XML, right? It's very simple to modify this recipe and say, okay, I want only wildcard.xml. I only want the XML files, right? Again, as deep as it goes, maybe 3 subfolders deep. I only have 1 subfolder, but it could be 6 subfolders deep. It will pick up everything, right? So it's just like looking through your file system. It will pick up everything. So again, notice I'm using something called list comprehensions, right? So how many of you know what list comprehension is? Yeah, you know. Yeah, you somewhere, right? So it's just basically a shorter way of making lists, very, very compact way, right? You have a loop here for file in. So this gives me generates a so-called iterator, right, of files, but I create a list of files from here, right? And matching XML here, right? We should have 10. Let's see how many do I get. Actually, I have 20. Well, at least I used to have 20. I still have 20, and I print the first 10, right? Okay, so that's okay. So again, if you don't like or not familiar with list comprehensions, you could do the same with a good old regular loop. It's exactly the same thing, right? You start with an empty list, and you append the files, and you get a full list. Same thing, right? So this is sometimes when you're learning, this is easier. Maybe this recipe is easier, right? If you don't like the syntax of the other recipe. Okay, but we have the files. Let's take a look at Jupyter. Right, so I have my, what do they call them? XML files, right? The same list, right? You can see that the contents, since this is a Windows computer, it says Windows path, right? So this code is made so it works on Windows, Mac, or Linux actually, because different operating systems have different ways of slashes. Sometimes there's backward slash, forward slashes, right? So with this recipe, it shouldn't matter, right? You should be able to pick up the files no matter what. Okay, we have a list of files, right? Now I'll show you some more recipes of how you could sort them, right? For example, I could sort by name, right? So how do I sort by name? I say, okay, there is a name property for each file, right? Because it's a path, right? So I say, okay, sort by name. And now it should be alphabetical, or well, in this case, it turns out to be, of course, lexicographical, right? So you see this is the first file, right? And so on and so on. We could also sort by file size. Notice, same thing, right? Except this recipe, I want to keep the old list, right? So I use, instead of using sort, right? I use sort here. I use sorted. So what's the difference? Sort modifies this list, right? This modifies this, right? Yeah, in place. This is one of those things, maybe this more, maybe Valdis is talking about this more, but so you need to pay attention when you're working with something, whether you are modifying what you're working with, right? Or whether you are creating something new, right? So this modifies existing, right? So the original sort lost, right? Here, the other recipe, other approach is you say, okay, here's something I want to sort, right? I want to sort by its size, right? So how do I, again, since I know each of these items in my list is a path object, meaning it's actual legal path, meaning some sort of resource, right? They have the size property. It doesn't matter which operating system. So I sorted by size, and let's take a look. Yeah, and so you see, okay, you can see the size in bytes, starting from the biggest one, right? And notice also, since the sort was for last 5, and I reversed the list, so this is actually, it's sorted from the smallest, actually, right? I took from the last 5, right? Yeah, and I then reversed them, right? So what happened is this, it actually, here, right, it was in reverse order, meaning from the fifth largest file, and the last one was the largest file, right? I reversed this order, right? I'm sure you have seen this. This reverses the list, right? You get a list in reverse order, right? So if I didn't have this, I could, of course, if I get rid of this, right? Control X, right? Let's see this. You see? Now this is the original order, right? It's fifth largest, right? And this is the largest one. So I reverse it, right? Again, one of those little things you will encounter in Python. Now, so first file is going to be, of course, with index 0. So this is going to be the smallest file, right? I think. Or did I? No. Oh, sorted by size. Well, I guess just any file. I could take the smallest one. Doesn't matter. Right. So I'll be working with this particular file. OBC, Old Bailey Corpus, right? 172. So I assume it's a year. I assume it's a year in April 27th of 1720, 18th century, right? So, okay. So now we could, So now we will explore this file. Is this the one? Yeah, that's the one, right? Again, since Visual Studio Code is just a text editor, we can see this here on Visual XML is a widely used format, and out of the box, Visual Studio Code supports it. So notice it knows the structure, right? So it's a nesting structure. You have these tags, right? You ever seen HTML? XML, it looks very similar, right? You have tags. On tags within tags within tags, like an onion structure, basically, right? So a nesting structure. And you can, of course, here's the whole content, right? You have the text, right? That's what we're going to be reading. And text has body, right? And bodies have here's a divider, right? Interpunction, I believe. Bless you. And Yeah, and so that's how, and there's the paragraphs, right? P, which we actually is very same as in HTML, right? And that's our content. That's what we want to extract this content. But there's also some things like surname, right? Who talked, right? This looks like a judge. I believe it's a judge, right? And judiciary name, right? Their surname, right? And yes, and so there's some extra structure in here. So let's see what can we extract from this. So we have this nesting structure, and we want to extract the textual content from it, right? And maybe some extra properties as well. Who spoke, what year it is, right? And to do so, we'll need to parse this. We'll need to parse things. So parsing means extracting structure from some sort of resource, right? So it is already structured. Just a reminder, this is just a textual file, right? You can open up in any text editor, right? But getting this data out, it will be much easier to use some sort of library. In this case, we can use the built-in library in Python, the XML E3, the element 3 parser. So let's get started, right? So basically, we want to get the whole tree, right? Let's see. This can get sometimes quite hairy, right? So probably most difficult part today, but see how it goes. So we have a tree, right? And we want to get the main element. So let's see which one it is. Let's see if we can guess which one it is. I assume it's going to be T, I believe, right? It should be this root element, right? This is just a metadata. It says what it is, XML file. And this it should be the T tag, right? I think that's a root, I believe, right? Again, that would make most sense to me, if I remember correctly. And let's see the root tag. Indeed, it should be. Let's see if that's the case. Still, it is root tag T2. Exactly. So what we've done is, using this element 3 module, we parse the whole textual content of this file, right? Parse, right? We provide a file name, right? We can also optionally offer a different parser. That's not really needed here. This would be needed if you have really difficult to parse XML. Sometimes there's some files which don't match the standard. The good news for us is, of course, this data comes from Clarin, so there has been some, there's some assurances that this file still meets the TEI standard. It's a validated file. I'm pretty sure it is, right? Meaning it matches this TEI1 standard. So who knows TEI? Text Encoding Initiative, right? Some of you have worked, right? It's a standardized way of marking data, basically, of structuring data in this XML format, right? So it matches this. Okay, so that's good. So here's a little bit more if this is your first time seeing TEI. Again, if you're going to be working in Humanities, I'm sure you will see this again and again. So in general, you don't want to invent your own standard, right? What happens is, I'll give you a little aside, XKCD standards, right? Let's see how my internet works. Yeah, my internet works better now, much better. Thank you, Artis, for your phone. So story goes, you have 14 standards. You say you want a universal standard, you end up with 15 standards, basically, right? Right? And it works for anything, for chargers, for character encoding, for XML standards, for instant messaging standards, and so on and so on. You end up with one more standard, right? So, yeah, so it happens all the time. Yes, yeah. At least, well, USB for charging, at least, thank European Commission, right? The European Union is, so we have the USB standards finally standardized, right? Finally, right? We can at least charge on the same standard. But yeah, so that's an issue. So that's why. So again, if you have a choice, go with an established standard. It's used by libraries, museums, publishers, individual scholars, right? So you have some text, and you want to sort of provide some extra markup, some data about it. You have some metadata, some named entities, some other things, right? So this standard is to be encouraged, basically, right? So. Right. It is relatively, what's the problem with standards? They try to account for many different use cases. It might not match exactly your use case. So it probably includes a lot of extra tags you're not going to be using. That's fine. You don't have to use the full power of this encoding, right? You can just use whatever small subsection. That's fine, right? Again, XML is very flexible, right? So again, we are not going to go into XML too much in this course, but again, one of the tutorials is from W3 Schools. It's not a very big tutorial. You can check what it looks like. Yeah, so you can see the idea, right? You have tags, opening tag, closing tag. And again, unlike HTML, which has specific about roughly 100 tags specified, these are open. You can make up your own tag, and come up, and it's still valid XML as long as you follow this standard, right? It doesn't have to be node, it could be my node, Valdis node, and it has to be closed Valdis node, right? If you want to make your own tags, right? It's still valid XML, right? But it would be preferably, it would be defined somewhere in your own specification, my text encoding initiative, right? But let's use establish this initiative. That'd be much better. Right. So, all right. So, documentation, you can see default document, right? So if this is our first time, for most of you, this is first time encountering TEI, and this will happen in your work or your research, you have unknown standard. You want to explore this and see what can I do with this, right? So we would check this documentation, right? Hopefully the standard has some documentation. Luckily with TEI you do have, but let's see documentation. There's some guidelines, there's it looks relatively overwhelming. There's lots of different language versions, right? It tells you this. Yeah, if you have some experience reading these standards, you can go to here, but I think better would be start with the default document, right? Find the default document, you see this example, right? And I think you can see how it makes sense. There's a standard, header, text, right? And it closes. Notice something here, right? I don't know if you can see this. I'll make this a little bigger. Yeah. So this is the name of the tag, right? And this is a property or attribute. This is attribute to this tag, right? It mentions where the standard, actually these tags are defined. There's a site, right? But it's not absolutely required, but this is a good practice. And also this close. This is TEI, right? In our case, we have slightly different data, right? We have TEI2 tag, right? So apparently a second version. But I think with some practice we can read it. I mean, again, I have a little bit of teacher's curse because I've seen a lot of different XML, HTML and so on, right? But I think this is relatively readable, not as readable as JSON. I like JSON even better. It's easier to read for humans, right? But again, the goal is for these standards is to be a dual fold, meaning for humans to read and also possibly write, edit, but also for the machines to read, right? To parse, right? So whether it succeeds for the human part, it's, some people, I mean, it can get really hard to read sometimes, right? Because you have a lot of properties. For example, notice this tag, right? Text, it's a text tag. It has what? It has an attribute created, date when it was created, right? Then it has URL, where it came from, apparently there, right? Name of it, right? It's part of some corpus, right? Again, and nobody says these attributes should exist, right? There might be a standard that says, okay, they should, but to be a valid XML, they don't have to, right? Main thing is you notice there's a body, which has no attributes. Then you have div 0. Again, that is interesting because, again, if those who know some HTML, there's a div attribute, div tag. But here they went with numeric system. It's kind of a little bit ugly because div 0, div 1, not very, how should I, not very nice. I don't think it's not too nice, in my opinion, right? This numbering, right? It's like calling variables A1, A2, A3, A4, A5. Not very, right? So, but okay, but that's what we have. And there's inter P, right? Again, it's a tag. I don't immediately remember what it stands for. Is it interpunction or no? It's something else. It's interpretation, maybe. You have to look up what exactly it's supposed to mean. You have to look up in the guidelines, right? I think you can search them through here, right? They consortium. I think I can. Let's do this. Interpretation. Okay, right? Summarize specific interpretive annotation which can be linked to a span of text. So span of text is some section of text, right? It doesn't have to be a single sentence. Could be overlapping sentences, right? So again, it just marks some data, basically, right? Interpretation, it's a collection, right? Again, so it's kind of like catch-all, right? Tag. Okay, but again, we for now, or on purpose for this purpose of this workshop, we're not going to go too deep in the taste standard. I mean, we could spend some days in it, right? We don't really need to, right? And the thing is, what I want to emphasize, you don't need to know the full standard to actually do some useful work. So here, we know there's some tags. We have the structure, all right? Again, we can see in any Visual Studio Code we checked, right? So there's some div1, and let's see div1. Yeah, front matter. So, trial account. Let's see this here. Juror name. There's also jurors. Let's see if we have trial. I'm doing it. Yeah, okay. And then we have the trial accounts. We have 87 trials here, looks like. Or let's see, trial account, right? 75 trials. So it looks like this particular file has 75 trials on that day, apparently. So it must have been, it seems pretty busy day. It must have been very quick like this, right? 75 trials in a single day, right? The judge must be just like, I don't know, hitting the gavel on, on going through, right? Okay. So let's go through again. Take a look. What's here? 1, 2. Yeah, it looks okay. Let's go back. Maybe go from 75. Yeah, it is 75. So it looks like div1. There's a tag called div1. It has some ID, property or attribute. Has type, trial account. That's what we want. And it has an n attribute, which has a number. Right. Again, none of those are required. But I mean, for this particular corpus, that's what we have. So that's what we're going to try to extract. We want to extract all of these trials separately. What happened that day, basically, right? Because we want to analyze what's going on there. How was criminal justice in England? All right, so let's take a look. So we know there's trial. And we want to extract all the trial account div tags, right? And then we want to get the plain text out of these tags, right? So for this particular purpose, we have a find all method, right? Which will find all the tags. Then we can go through them. We can get attributes. We can get the values of these attributes, and we can get text of the tags. So again, I will be using list comprehension. So what I'll be using is something called XPath syntax. Right. So this is relatively little, maybe less known than general HTML, because I'm sure most of you know some HTML. But this syntax is very powerful. So basically what I'm saying is here, I want all div1 tags, no matter how deep they go in this root document. And this div1 tag should have a attribute type with the value trial account. That's all I'm saying here, right? So this is a very compact way of writing my requirements, right? I'm sure, by using this recipe, you could come up with your own. Like if you need some other tag, you enter your own name here, any other attribute, right? You come up on what the value is, right? And this is very compact. I'll show you in a moment, I'll show you the way, if you don't like this XPath or it seems maybe too complicated, how to do this without this, right? So again, there's a introduction, XPath, right? Again, very, very, very powerful, right? But maybe not so. There's a tutorial if you want to have some free time. Could be useful. So let's see if this works. I should get 75. Do I get 75? Yes, I did. Very good. So very good. So we got 75. And now I think I have, I think so. So if XPath is not my thing, so what we can do this. So this is a simpler recipe. So basically I start with the empty loop. So start with an empty loop. And I'm trying to see, again, it's still my Copilot is unfortunately not picking up, it's still just spinning and spinning, so I have to do everything myself. But okay, maybe we'll have some simpler notebook later on. So what we do is we have a root document, and we're saying this. Find div1 tag, so meaning here, go through all of these. At the moment, you don't know what kind of attributes they have, right? Just get me everything, right? We loop through all of them. And if there's a type attribute, if there's type in my attributes, right? For this particular one, right? And if this attribute has trial account value, then we append it to our list, or ever-growing list, and it should be exactly 75 long. So this should be a simpler recipe with using 4 loops, ifs, and 2 ifs, nested 2 if statements. And let's see if that works. Again, 75. Right. So again, we could check our values here. Jupyter. There we go. Tile accounts. Yeah, you have. Okay. And it says it's an element, right? It's an element, 3 element, right? So we're not yet home free, right? We will want to extract some data out of it, right? So we have our elements. So we want to get. So basically, this is even another approach, sort of like in between the first very compact way, this second longer way. We can use a get. So get means if we get a trial account, we have a single if, right? So what's the difference? Look here. If type, we have to check if there's type exists. Here, because we can use sort of like dictionary approach, right? You all know what dictionaries are in Python, right? If there's no key, we will get an error. That's why we have to check here whether the key exists, right? Here, I use a get, meaning get is like checking whether it is. If it doesn't exist, if this type proper attribute does not exist, we'll get none. So this if will not, basically we won't get error, we'll just get a false, basically none, right? So none as a default. So this is a shorter way of writing. I like this approach, but this is completely fine too. It's basically this single get combines these 2 ifs basically. Okay, so now it should get also 75. Yep, okay. All right, so now let's get our first trial. So we have our 75 trials. Let's get our definition, some text from trial. So we will need some text processing, basically. We can use, these are just regular string methods in Python. We can strip some text, right? Strip white space, trailing white space. We can use replace to replace new lines with white space. Why would we want to do this? Because we are going to probably be splitting it in the words. Maybe we want also tabs with white space. Again, it's up to you, but depending on the corpus, what you need to remove in this pre-processing step. And maybe also carriage return, which is kind of like new line, but some files have this. So let's take a look. Let's get text. Let's try to get text, and I have a comment here. I'll get nothing, and I'll like it. No, but I'll get nothing. But I'll get nothing, meaning I'll have an empty string. Let's see if that happens really. Yeah, I get nothing. Right. So why it happened is because let's explore this again. Where's my first trial? Okay, here's the first trial, but notice the text is not here. It's actually part of deeper structure. It's not in div1. It's inside. It's one of the child elements. In this case, probably person, yeah, these are the victim. There's a victim. There's interpretation, acquitted, right? So paragraph, and that's it. Sentence of death. Yes, horrible. But right. So, but yeah. So that's what we're trying to extract, right? What happened here, right? So, but we're not getting anything. He was stealing, and he got the sentence of death. That's really that bad. We'll see. Wow. Okay. All right. So let's take a look at this, right? So justice was pretty rough in those days. So, so now let's see if we can get the first trial. So what we can do is we use trial accounts iter text property. And again, this comes from what? This comes from this ET built-in library of Python. Again, if you had just regular string, there would be no iter text. This is because this trial counts 0, right? Is actually this element. Let's take a look what it is. Oh, sorry. Escape A. Why isn't my escape not working here? What's up? Okay, yeah. So escape A makes a new cell above, right? Or I could just make a new cell here plus code, right? So type of first trial account 0. Trial accounts 0 is element. Yeah, unfortunately, I'm not getting any assistance today, so I have to do everything myself. So type print type of first trial equals type trial. Sorry, not like that. This happens when you are so used to trial accounts 0. Let's take a look what kind of data it is. Yeah, it's XML element 3 element, right? So if there's like regular string or as a list, you would not have this iter text method, right? So methods, of course, are attached to objects. I mean, they are defined in class definitions in Python, but they are attached to objects. It's things you can do with these objects, right? So you have element, so you have this property, right? So let's see. We are going to get any text. We're going to join it with a white space. Let's take a look what happens. Do we get anything this time? We get nothing still, and we still like, oh, we got something. Oh, we did get this time. Look at this here, right? So we got some text. This is the first case, right? He stole 70 pounds of tobacco from Job Wicks, right? And he was a servant there, right? And guilty to 10D. So 10D, this is a 10, not shilling. This was pennies, right? D, I think, stands for denarius, I believe. All right, and this is in an English system. That is pennies, right? So I guess that's no relative. But that is the value. But that's a judgment, transportation. Do you know, guys, what now transportation was? Yeah. What kind of sentence is that? What does it mean? Do you know? Yes, I think it's by 18th century, maybe not Australia, but you were transported somewhere in some ships, right? So later on you go to Australia, but basically, yeah, they shipped you somewhere, one of the colonies of England, right? And that's where you spent your, and you make Australia great, basically, right? So, yeah, so that was pretty common sentencing, right? So, all right, so. Now we want to get we want to get this transportation. So right now we got all the text, but I think you'll agree we lost a lot of this valuable information. What's in there? Right now we would have to, we could maybe extract some of it using some AI assistants to see if it reads and see who is who, right? But we already have all this work here. We already have this. Let me go to first one, yeah, right? This first we already have. What he stole, right? We know the victim, right? We know the name. We know where it happened. Defendant was name, but where is the actual defendant? I'm trying to find this name. It's actually missing here, right? ID, but we know where it's from. Maybe his name is redacted. I don't know. Maybe there's a date, 8th of April. So this was 27th of April. So it was like 19 days later. Pretty quick, right? So he got, in 19 days, and you're off to Australia, right? So steal some tobacco. Okay, but so we want to get this, right? So join result punishment, right? Transportation, right? So this is what we want. Okay, but this is what we want, I think, right? Interpretation of type punishment category, right? And we want to get the value transport. So this is what we want to extract, right? Again, this particular type of XML is using this way of structuring, and we want to extract this. So let's see if we can do this. I think we can, right? So this would be one way of doing it. Find, instead of find all, we find the first match, right? Find all gets you everything that matches this, right? Here we are saying, by now you should be able to pick up on this. I say, I want to find RS tag, which has a attribute or property type, which has a value, punishment description, right? And we can print it. Okay, let's see if it works. Yeah. Yeah, that's a punishment tag. So we got what? We got this here. We got this basically, right? This is what we got, right? And we want to get the, and we want to get everything. That's what everything in there, but also we just want to get text out of it, right? And we got transportation. So here, this is not the only approach. So this is relatively, I got the textual value, right? But also notice I could have gotten this part here as well, right? I could have gotten also this. That's another approach I have taken. I could have gotten transport, right? This is even better structure, right? I got the textual value, which I think is, well, I think it's fine here. In this case, it does not, two ways of approaching this. But we know, okay, we know what the sentence is. So if we can get it, we can get a sentence for one trial. Obviously, we can make a loop and get it for all the trials, right? So again, when you're working with some data, you see you want to get on single example, and then you want to make it generalized to a bigger set of examples, bigger sequence, right? Then it makes sense, right? If your approach each time changes, then it's not very scalable, right? If you have sometimes something changes, right? So sometimes, of course, the structure is not so set, right? You need to find what's common, right? And then only you can, make the computer do the work, right? First of all, you may have to do your human work, your specific work, and then you can make the computer do the loop. Okay, so we can get the text punishment. Now we could get a name, right? So how about getting the year of this, right? So again, different approaches, but I can show you we can get the year from here, right? Again, very common when you have a file name, you want to extract some parts from the file name. So we want to get the year. I think this is where hopefully we'll get to regular expressions, or we'll just use a split. Yeah. So I'll show you two approaches, right? Maybe I'll use a regular expression. Yeah. So there are two approaches here. So we have a string with a file name, and we know there's a year inside, and the year is the first 4 digits after this dash, right? So if we don't know regular expressions, we could do split by dash, right? And we take the second part. And then we take the 4 digits and we convert to integer. Let's try it. That's the name. And it should work. Again, what the issue is with this, I'll show you what the issue is, right? And yes, so file name is this. And I have two approaches. So one is the split by dash and take second part, and then first 4 characters from the second part, and we convert this to integer, right? And second approach is using regular expressions. I can highly recommend regex 101. Yeah, this one here. Anyone use this regex 101 for testing your regex? Yeah. So you can basically have your text. Maybe you have something OBC 2024, right? And you can insert, right, this regex. Where's my regex? Here we go. And yeah, so this means digit, any digit. We want 4 of them, right? Just 4, exactly 4, right? So if you insert here, well, notice it picks up on this one and picks 2 groups. It has 2 matches, right? Happens. If I had, of course, also, this is a problem also. We want exactly, right? Regex can get extremely complex because, of course, your structure of your text can be complex. If you only want the first one, in this case, it's easy for us. We want the first match, right? We don't care about the second or third match, right? Because in this case, we actually have multiple matches, right? If I had this, I'll copy this, right? I'll show you, right? I'll copy a new line, right? Notice, right? So it matches first 4 and then the next 4, right? So you actually have 4 matches here, right? Yeah, you have 4 matches. So, but in this case, or regex, again, we're not going to go in a full-blown regex discussion, but we just get this exactly 4 If I said 2, I get multiple matches, right? 3, 5, right? But I want 4, exactly. There's ways of specifying what you want to follow, but we said, so D, right, stands here, any digit. On curly braces 4, we want 4 digits, exactly. So, search, right, regular expressions module, search, match, and we find the match product. And let's take a look if this works. XML name, and oh yeah, and we get the first one, right? Let's take a look. So both of these approaches are fine, but there's one downside to this is, of course, if you have a big list of files, maybe one of them has something not quite up to this, right? That might happen if you're working with 100,000 files. Artists can attest to this. Sometimes there's might be for some reason, maybe there's an error or something, and it just doesn't work. So you might want, of course, see if maybe this raises an error. Maybe things to do. I'll add this here to do. It is possible an error is raised. Then we would want to include this code in try. Try something and then accept, right? Then you see accept, right? Accept, do something, right? Do something, right? And then handle specific exception, right? That might be something you want to do. All right, but that's something to if you or maybe you want to also do. You can check if it's if statement. If there's actually do you actually have anything did you actually get anything? Because if this match doesn't find, you'll try to convert maybe nothing to integer, you'll raise an error, right? So, but again, but in this case, we're lucky, well, not lucky, but nicely organized, this is mediums, not very difficult case. So, now, next recipe would be, but how are we doing so far? Can you follow, guys, still? Okay? Right. So now we're going to look how to get the trial number. Remember, there is an N attribute, right? And then, yeah, like this attribute here right? So we want to know what number of day, what is the number of trial for that day. And in this case, well, we could just count, right? We could just count them in order, right? Because assuming the numbers are sequential. But that's one way of doing it, but of course more precise, assuming maybe there's some jump, maybe the numbering, maybe there's some mix-up, you don't know. Use the actual attribute, right? So we know that trial accounts have an attribute, okay? And again, this is not always, again, it could be a case, maybe, sometimes, instruction, creating this text, there will be errors, but it looks like all of these attributes present everywhere. But let's take a look if this works. We know it works for the first trial, right? So let's take a look. It should give me 1. Indeed, it is 1. So the first trial with a 0 index, right? The first one. Yeah, there's an attribute, right? So this is dictionary lookup, right? Right? We have a key n in attribute dictionary, and we look up the value. So again, for your basic Python skills, dictionary, being comfortable with dictionaries is essential, because essentially some people have said that writing Python is basically making a whole bunch of dictionaries, right? Efficiently working, right? Because we look up attribute by n. So now what we want. So let's get all the data, right? So let's make a function in one. So now when we work on notebooks, we have these little experiments. It's a good practice when you have something working to create a function. To create a function of what works, so then you can apply it to more instances of this data, right? You don't have to copy and paste this copy, right? So you create a function, right? And it will work on any file name, right? If it's a path, right? So if it's instance, fine, right? Now this is not a perfect function, right? Else return nothing, right? Else, I would say this, else return nothing. Again, right? I don't have, right? Because or maybe could return year 00 or something else appropriate. Okay, right. But here we're basically then going to get the integer, right? And then with trial number, that's what we just did here, right, in the previous cell, right? So we have these two functions. What else do we have? We get punishment, right? That's what we did first. So we get punishment. So assuming we have this div1 element, we'll get the punishment, right? And otherwise, if we don't find punishment, we get nothing. We return nothing. Also, we have text. We can find all text. We can get clean text. All these functions. Now, let's create a function that will extract all the data from a single trial, right? So we give it a div1, right? Div1. We give it a file name, right? And we get the year. We get the trial number. We get the punishment with text. So what are we returning? We're returning a dictionary. There is the reason why we're returning dictionary. Why? Because we are going to be feeding these dictionaries into a pandas data frame. And dictionaries are great for creating pandas data frames because what's going to happen is these are going to be column names and these are going to be the values, basically. So we're going to be providing a list of dictionaries and we'll have a huge, nice tabular format, basically. So the idea of all this, what we are doing is we're going from this hierarchical, this tree type of structure into a flat two-dimensional structure, right? Again, we humans have a hard time with these three structures. With two-dimensional data, it's much easier to work. So that's what we are actually trying to do. Okay, so we have all these functions, and let's test it. So I wrote all these functions using this code we already wrote previously, and we can extract data from the first trial. Let's see, it looks like it worked. So year none, well, it didn't work. Trial number 1, punishment transportation, okay, that worked. Text is full text, we got also the full text, okay. That's good. So why didn't year work? Let's take a look at year is none. Let's take a look what I actually did some change. Maybe I was a little bit hasty. Get year, if it's instance, so this part here, okay. I think what happened is this actually was not needed. That's what happened, right? So what's happening here, if it's just a string, maybe file name is just a string, actually it's possible. Then we don't need this. Again, this is for full, how should I say, for full stability, we would want to handle edge cases, right? Such as when we do not get a year from the text, right? So meaning empty match, right? But okay, that's something to do, right? In this case, we are lucky. Our file structure will always get a year in the file name. All right. Now let's take a look again, and I'm going to rerun the cell again. So we'll get we'll get all the data again. On yes, we got the year. Okay, yeah, that makes sense. So I think what happened is basically the name actually was a string. Yeah, that's a string. Okay. So if we can do it for a one trial, we can do it for all the trials, right? So hopefully, so now the easy part. The function to get all the trials, we just give it a list of trials, right? These are going to be a list of elements. And we are going to run it for each of them, and we'll have a nice little list of dictionaries, right? We got a single dictionary. And we'll have a year, trial, punishment, right? Year, trial, punishment. Again, we could also get I don't know how much time we have. I'm kind of itching to do some extra stuff. Maybe we can get even without the assistance. I don't know if I'll try to do this without any AI assistance. I would like to get we can get the months, of course, as well, right? We can get the months. What's the easiest way to get the months out? Let's take a look. I'm not quite, right now when you're looking at your code from you did before, you say, okay, why did they write this? Maybe you could do something better, right? If you look at your code from 6 months ago, you say, okay, who made this code? Why did you do this, right? So let's see if there's year here, but the month is not really, well, maybe it's somewhere. Yeah, you see it's 27th, 28th, okay. Well, I think we can get April. We can get April from here if you wanted to, right? Or we could leave it for later. One other approach we could do is basically here is year, the file name. We could ship the file name actually. I think would be good to actually have the file name. I'll leave it for later on processing. So not to lose this information, I'll do this file name, right? File name. Again, this is not required, right? To keep, sorry, not like this, but so key file name to keep the original reference for maybe to get months on day maybe, right? From this, right? Just a quickie. So basically add an extra column. So let's do this again. Or rewrite this again. So now I should have file name is still present. So I know where this came from. Again, this is not required, but this is kind of say, okay, if you ever encounter some problem analyzing, okay, you know you have a source to return to find out where did you get this data. Okay, I know it came from OBC, this file name. And then you can see if something is wrong with your analysis, right? Again, it doesn't cost us anything extra. So now let's take a look what we get. We have number of trials 75, and here are first trials. We know the file name, right? It's the same file, of course, obviously. But again, remember, we are going to be going through not just one file, we're going through multiple files. That's why we are keeping this file name. We have a trial number, punishment, transportation, so they're all punished, right? And there's a full text, right? Yes, there's a full text of what's happened, right? Also, now get all trial data. Let's take a look. We get a get list of trial data. So it takes a file name, and we are going to do everything. So we have file name, tree. We're going to parse the tree. We get the root element. And then we get all the trial accounts. And then that's what we needed to get all the trial accounts. And then we basically use the other function to get a list of these dictionaries with our file trial accounts. And all we really need is to have the file name. And that's it, right? So of course, it's up to us to make sure this actually is a real XML file with TE format, right? We don't handle all the extra case when it's not a real file. But let's take a look. And now it nicely works. Okay. Oh, but I don't like this approach. File name. Right. So this case, well, we could save this, but do I really want this? No, I don't really want this. What I'll do is trial accounts. I'll do this name. I'll call it name. Yeah. Why do I do this? Yeah, let's take a look now. Yeah. So what I did is I didn't want the full path name. I just wanted the actual file name it came from. Okay. Now it works. Now how far are we? We can read the single file and extract all the trials from a single file. And now we can move up and we can extract from all the files in the folder, right? So moving from a single instance inside the file, now we can move on to all the files in a single folder, right? So what we'll do is we'll use extend, right? Instead of append, right? Here's the thing I mentioned with list operations. Lists are a way of storing data in sequential format in Python. What's the difference between append and extend? Append adds, right? Extend sort of flattens the data. Let's take a look at differences. So you have two lists, right? Look at this, right? If I use append, right? I basically get a nested structure. Sometimes it's needed, but in this case we don't want. We want a flat structure. So that's why I use extend. So that's why the this will give you a flat extend of 456, right? Another way is plus equal, but this is what I think is most clear. So extend and append. These are list methods, right? So what we'll do is this. We have a file name, right? So what we'll be doing is we'll be creating from a list of files, we'll be creating a one big list of dictionaries with all the trial information, right? So start with an empty list, extremely common in Python. You have an empty list for start, and you go through all the file names on somebody, okay? So, and then you extend this list, right, until you have no more files, right? Let's test it. How many will we have? Probably, I'd say, okay, 75. I don't know, 75 times 20, so about 1,500, but we don't know. Maybe some days we're busier than others, right? We'll see. So I don't know, I don't remember how many. You can probably see this down below. I'll say about over 1,000 probably, right? Maybe towards later on, maybe they get a little more slower. Let's take a look. Does it work? All right. No, I was close, 1,600. So yeah, it actually got even more efficient, right? So 1,600 trials over 20. So we have, and what I did is this. I took a random sample. Again, not very, death, transportation, no punishment. Interesting. Sometimes punishment, there's no punishment. Something that means we have to maybe explore this. It's not, looks like it's the punishment function is not perfect. Sometimes it picks up exactly, but sometimes it gets you empty states. And maybe we could, of course, we could check what's happened here, right? We could check, because these are not very big trials. Oh, actually, well, took all the money. And what they do? Not guilty. Ah, that's good news. There's no punishment. That means that they're not guilty. Okay. Well, I don't know if it's good news, but yeah, not guilty. So if there's no punishment, means they were not guilty. Yeah. Good to know. All right. So now I mentioned already why we are doing this in this specific format is we're getting a list of dictionaries. So we will be saving it as a pandas data frame, and then we can make it nice, flat, two-dimensional structure. Right. So we have a list of 1,637 dictionaries, and since each dictionary has pretty much, actually has identical keys: file name, year, trial number, punishment, and full text, right? Or text, I call it text. Okay, so those will be the column names, right? We'll have a data frame of 1,637 rows with these 5 columns. Okay. Let's do it. So, it's really simple. We have a pandas data frame. If you have a list of dictionaries, you will be able to create a data frame. Let's take a look how it works. On. Yes, indeed. So, we have file name, right? You have a year, trial number, punishment, and text, right? You don't see the full text here, but it is. I can assure you, it is present there in the data, right? It's saved. But again, when I say saved, it's in the memory, of course, right? It's not if my computer was turned off, you would lose this data, right? So we will probably want to save it next, I think. But let me remember this. Right? Yeah. So now that we have created this two-dimensional structure, we'll probably want to save it. In Pandas library offers many options. So we have something called a data frame, right? Again, which is basically a table, right? Actually, I think it comes from our language, or no, actually before that, actually data frame concept. But it's basically you have each column has a specific data type, right? And you can work in, of course, with columns, rows. You can do all kinds of operations. We'll do a few operations later on. But first, for now, to be safe, we want to save it, right? So let's do a stem. Actually, I could do it automatically. I'll do this automatically. Let me show you. Let's create a file stem automatically. Unfortunately, again, so file stem would be what? I think I had file name. Let me check, remember what I already forgot my variables. All right. File name. Yeah, file name. Here it is. So file name. But that is actually first file, right? That's the one, right? Yeah. Or sample. That's a file name. This is different file name. So we want this one, I guess, right? Old Valdis sample. Okay, so file name. But I could do this. I'll show you another recipe. So file name and then stem, right? So we can use this pass, right? This is Python library, right? To say, okay, I don't need to write my own code. I want to get this out, right? File name, so file stem. Let's see if this works. File stem is, let's see. I think it will work. Yes, it is. It worked. You see? So it worked. So we used pass to call its stem property, right? So we converted pass file name string to pass object and used its stem property, right? And so we don't have to do it by ourselves. I mean, we could of course do splitting, try to find ourselves, but this is very convenient, right? So again, so you know how to do this. So this is the approach we could do it. So we can use this approach here. I'll comment this out. Shift Alt arrow. No, where is my? Yeah, Shift Alt arrow, or I think it's, I don't know, on Mac it creates, you duplicates a line here. You see edit, where is it? File, edit, oh yeah, here, selection. Oh yeah, copy line up or copy line down, right? Shift Alt, a kind of useful shortcut sometimes. You need duplicate line. So I'll comment this out, Control // right? And I'll use this approach here, right? Yeah, this one here. And then, without the zip. Okay. And then, since this is file stem, we can do this approach. We're going to add the .csv to the file stem. Again, obviously, if it's just a single file, you could do it by hand, and you could type out the whole thing here. But I prefer to make it automatic, right? So in case if you make multiple files, right, you will have an approach which will be general. It will work over any number of files. And then we'll save it. Now, so data frame has a toCSV method. It is an extremely complex method because CSV files, separated files, they don't have a full standard. Actually, CSV is just sort of like, everybody kind of knows what CSV is, comma separated values, but there are many, many variations. And that's why Pandas, based on all different requests, it has many different options, how you want to save. Do you want the comma? Do you want to escape the quotes? Do you want what kind of encoding? Do you use like encoding might be quite important if using Latvian or Spanish or some other language, not English, for example. What kind of data format? There's many, many options. Quite difficult, complex method, but in general, here I use the default values. What I do use is index false, right? Why? Because those numbers that index is just a numeric, it's not really doesn't show anything, right? So I don't want the index column. If I want index column, of course I will. So that's CSV. Now Parquet, what's a Parquet file? I don't know, some of you have used Parquet files. It's basically a way of preserving the data information, the types, and also of store it compactly. It's much more, it preserves this extra type information which CSV files will not. So CSV files are not perfect in that regard. Also, I'm gonna risk it. I don't know if it's gonna work for you guys, but let me also save to Excel file, right? Maybe let's do Excel file. Why not, right? 1600, maybe somebody, I don't know, your supervisor, maybe your colleague who only wants Excel, they don't know any Python, they want Excel. You can give them Excel. All right. So same approach, right? I'll just copy this, right? I'll call it Excel pass. Of course, I don't have to do this. So Excel pass, right? On temp, and I'll do XLS, right? XLS. Of course, it doesn't have to be exact, but yeah. So files temp plus XLS. And now, of course, df to Excel, right? Notice here, 2. You have, I think, about 10, 12, I don't know, different ways of saving your data. You can save to the clipboard. You can save to CSV, back to dictionary, Excel, Feather is another format, GPQ, HTF, HTML, JSON, LaTeX, LaTeX, Markdown, NumPy, different formats. Oh, there's more. Parquet, Period, Pickle, Records, SQL, Stata, which is data, statistical software, timestamp, back to XML if you want, but it's not going to be, it's going to be different XML. All right, so let's do it, right? So we'll do Excel, right? Excel, it should, yeah, Excel. And of course, here again, I will use Excel pass, right? No Excel writer, Excel pass, right? And index is none, right? Index false. Again, because why? It's not, there's no real index in this case. Okay, let's say there's one downside to this, that this might not work because you might need some extra library for saving to Excel. Excel has some extra requirements. Let's take a look. I'm not sure if this will work. Let's take a look. And will we get an error? I think we'll get an error. No, it got everything. Okay. We saved everything. Let's take a look. So this one is not going to be present. You can see this, but you can see this approach again. This part here, maybe I'll do it again. Excel pass, right? Print Excel pass. I'll just show it again so you can try to do it yourself. I don't know if it's going to work on a Google Colab. It should work. I think they include Excel support. Okay. Yeah, 1.9 seconds. So you can see where you're going to, in this particular computer. So you will see where it's stored on your computer or your Colab, right? So again, it's in temp folder. It could be any other folder, but yeah, so temp folder. Now I have these files. Let's take a look. Indeed, I have them here. Excel is something new. Let's explore this, right? Since I have Excel 2, Visual Studio Code does not have built-in support for Excel. CSV does have support, of course, because it's just CSV, right? In fact, there's a plugin. I'm not a big fan of it. It's not official Microsoft. It's something somebody called Mechatroner. I don't know. But I'm not going to install it. Sometimes Visual Studio Code suggests some plugins, but I've used it, but it's okay, but it's not great. So, but you can see, yeah, that's how we saved it. You see? That's how we saved it. And you can see the issues sometimes. What the big issue is, of course, that with CSV files is that comma, right? What happens if there's a comma in text, right? That's one of the big issues. Now, that's why you have quotes then, right? So Excel is quite nice. Excel in a way is similar to Parquet because it will preserve this information. Let's take a look. Reveal in File Explorer. There's my Excel. And let's open it up. If you have Excel installed. Yeah, so you can see. Right. So that's why I didn't use, if I had the index, I would have an extra column here with 1, 2, 3, 4, 5, which is kind of useless here. So you have also the full text. So this is a very typical approach of storing, corpus documents with some features. In this case, of course, the number of features is very limited. They just have year, punishment, and trial number, and the file name. But I could possibly have maybe 10 or 20 features. Maybe who was the victim in this case, who was the judge, and so on and so on and so on, right? But for now, we have just we have the now where it came from, and we know the text, right? Which we can use to do some extra analysis, right? Okay. So transportation, death. All right, so who got death? Hopefully didn't do, what do they get for death for on 13th? But some people got, actually, so there's quite a few also innocent people, right? So we'll be analyzing this later on. Okay, so we have our data frame. We saved the data frame in 3 different approaches. We saved as a Excel, say there's Parquet and CSV, right? So CSV is the one which is easiest to give somebody who has no knowledge of the formats. They can open up the text file and see what's inside, right? So we will probably need some more cleaning, right? So yeah, so this we are getting close to our data reading. So some extra discussion. What other formats? PDF is probably the worst to work with. PDF, right? So because first of all, there might be text inside, there might not be text inside, but the text fragments, if there's text in PDF, right? The approach of extracting is extremely difficult. So that's probably the worst one. If you all have PDF, that's the worst case. docx is okay, but not great. HTML, text, CSV, relatively easy. JSON, very common. It's very common to get data in JSON, and you extract some things, right? So quite nice. XML, so XML and JSON are probably the most common, and CSV, of course, right? So, question was, so what's your favorite file format? What's text? JSON, yeah, I like JSON too. I prefer JSON format because it's much nicer to eyes, basically, right? What's your least favorite? XML. Yeah, XML, yes. So we got through the XML and with minimal damage. So, so what's the most common? Yeah, so question is, what do you actually use daily? What are you forced to use daily? What's your most common format? JSON mostly, right? Take plain text, maybe something else? CSV files, yes, you have to use CSV files. Yeah, all right. Yeah, so we have a couple more minutes, but we actually are, we are doing it now, going to move on to processing part for today. Now we'll be reading some data. I'll just set it up for you for now, right? Also going to be our second part. We're going to be now transforming this data into more digestible format. But let's see, we have like 5 minutes maybe before starting this new notebook. What can we extract more? Unfortunately, I really don't have any assistance, so I have to do it completely. I feel almost without my personal assistant, right? So I have to do it myself. I could, of course, ask Google, but I don't want to ask that. I could ask, of course, ChatGPT. That's also not the same. Let's see what could we extract before the. I want maybe the victim name. Maybe I could do that. Maybe. Let's see. We still have all. But before I close this notebook, because when I close it, I'll lose all the memory, right? So let's go to trial data. Yeah, here we go. We just need one more function. I want to add one more. Get punishment. Maybe get victim. Right. Now let's explore this. What was it? 7427? Was it? Oh, this one, right? Yeah. Yeah, this is the 4th of April. Okay. So recorder. We can get the judge, of course, but juror name. We could also extract, in this case, all the jurors and the judge, of course, are the same for all the trials in this case. So we could add this information also to the trial information, right? Make it flat, basically, right? It's also possible to do that. Maybe we get judge, but I don't know. It's not going to be in this particular case, it's not going to be very interesting. Jury, let's see what else could we extract. We have like 5 minutes before we go to lunch. Okay, div. Year we have already by itself, collection Bailey, we have criminal charge, genders. Let's do genders, right? Defendant genders. That might be information. Okay, so let's look at this. We want to extract the gender. I'm not sure it's always going to be. I'm going to see this if this is actually present 75 times. It's a little bit dangerous. It's actually important more. Okay, that's Carter. So what happens means we have to extract what? Type defendant name and then gender, right? But that's not all. I have not checked this. It's possible there are multiple defendants also. Maybe right? So that might complicate things. So let's try see how many defendants we have. I'm guessing it's not 75, but let's see. Maybe there's 75, 85. Yeah, so there's 10 more. So in some cases there's multiple. Yeah, so that complicates things because we don't have a nice, tidy format to put in single value. We have to store a list of names in this column, right? We can do it, but it makes analysis more difficult. So I could, of course, search for first defendant, but it might be interesting to do it. But we could extract this, of course, right? The gender, right? Also victims, of course, victim name. Victim, I think there will be more than one. Also, same thing. If you check for type victim name, it will probably be 82 again. So more than one victim sometimes, right? So again, not makes things harder. Also, the verdict sub, because there's also how much value, how much you have to pay, right? Punishment, right? We can also get the punishment category, right? Tag order. Value transport, yeah. So again, so that's it. So there's some things we could also explore here. But I think it's enough for our first part. Now that we have our data saved, we will be doing some extra processing, right? We have a nice tabular format. We'll do some extra processing after that. All right. So any questions on what we've done so far? You all guys good? So Colab worked for you. Local installation worked. So how many were able to do this locally? 1, 2, excellent. Super. Very good. So I think we have an hour for lunch. So this time we are going upstairs, I think, not like previous years, right? Just regular lunch, right? Yeah, okay. All right, so thank you. So I'll see you guys here at 1:30, yeah, in an hour.